Okay, so welcome everybody. Thanks for joining us today. So our session today is spring is here and the Leafs are out. And surprisingly, I'm not talking about the Maple Leafs today. So LEAFF stands for Linear Energy Analysis for Fenestration. Sounds pretty intriguing and possibly complicated. Any manufacturer using NFRC for their thermals has by now probably heard of LEAFF, but I expect most don't understand exactly what it means for them. Relying on your lab or simulator to do what's right is okay, but understanding what changes and better choices you can make with LEAFF will help to streamline your thermal performance compliance and testing. Will that LEAFF methodology simply simplify your NFRC simulations? So let's find out. So my guests today, Taylor Wight and Jonathan Layton, hopefully once Jonathan gets here, with Layton Consulting out of Vancouver and Karsten, you said, not Edmonton. So good morning, Taylor. Why don't we start by just having you tell us a little bit about who you are and what you do.
Yeah, you bet. Let me just see if is my screen coming up there? Awesome.
Yep, you're good.
Okay, so yeah, John goes by Jomo, and hopefully he'll be joining us shortly. And I'm Taylor, and I work remotely out here in Alberta. And we do, with Layton Consulting, we've been engineering consultants for quite a while. Jomo, his dad actually started the company, and we started off in the structural engineering side of Windows, and we've gotten into the thermal simulation side over the last 10 years or so. So let's see if I can. Here we go. Okay, so lots of you are very familiar with the window labels that go on windows for thermal simulation or certification rather, that show the different ratings that windows have. And NFRC and CSA are harmonized in the method that they use to rate windows. So in North America, NFRC, which has started in the States, they've created the method for rating windows, and it is different. I just wanted to throw it out there that it's different than what the Europeans use, and there's definitely some confusion there when you're bringing products over from Europe. They do have a U factor, and they have a G value, which is similar to our solar heat gain coefficient, but the methodology is quite different. So I won't go into depth with that, but I just wanted to point out that in North America, NFRC and CSA it's the same method for rating windows here. So when we're rating a window, we use Therm, and the software Therm and Window is called, to rate the window, and it breaks down the window into three main components. There's the center of glass U factor, and that's actually similar to like an R value rating that you would have for insulation. It just assumes that the glass is infinite in all directions, so it takes the sort of the center conductivity of that glass, and so that's usually your best rating. So if someone on a project is just giving the center of glass values for the U value, then that's a bit false, because you have to include the frame and actually as well the edge area, which is kind of a transition into the frame. So those components make up the whole product rating, which we call a U factor, because instead of a U value where it's consistent throughout a U factor. It combines all of those values into one. So the trick with this is size matters, because the frame is often the worst performing. So the amount of frame to glass ratio matters with that U factor calculation. So if you have less frame area, usually that less frame area to glass ratio, the less frame you have, the better the U factor will be. So in other words, as your window gets bigger, your U value will drop and will get better. Conversely, if you have a smaller window, you'll have a higher or worse U factor. So just something to take into consideration, and NFRC realized this a long time ago, and so they came up with standard sizes for all different windows. And so you all have, I'm sure you're well aware of all the different standard sizes for all your different products, and they don't always line up, I know, with what's actually installed on projects, but we have to be able to compare apples to apples, and so that's why we have those standard sizes. Yeah, I just wanted to reiterate that as the U value goes down, that's better. It's the inverse of R value. So as a U value drops, that's a better rating. So you can think of lower is slower, a slower heat conductance. So you want a lower U factor. Okay. So this just kind of combines, I mean, there's the formula that combines all of this together. And this is kind of an overall overview of the way that we calculate U factor. And I just wanted to bring that up to sort of start us off, because all of that is the same as it's always been with NFRC. So none of that is really changing. But I wanted to go into now what is changing with this new LEAFF method. And as spring is here and the leaves are out, I love that title, by the way. But so that's what we're here to talk about is the new method. So what is LEAFF? So LEAFF is a trend line approach. Many of you know with a trend line, you have a slope and an intersect, and that line will be straight, and you can pick anywhere on that line to pick out exactly the applicable U factor for your exact type of window that you're using. So to get a line, you need 3 different points on that line to establish an appropriate trend line. Obviously, with 1 point, you can just move that line wherever you want. With 2 points, you have a slope, but you don't know exactly how accurate that is. And with 3 points, then you can have a slope, an intersect, and a tolerance for that line. So so that's kind of the thought process behind what LEAFF is. It's a trend line approach, and we'll get into that a little more here. So this is what the trend line looks like, and I'm focusing more on the dark blue line that slopes upwards. That's our U factor. The other lines we'll get into later, they deal with the condensation index. But that dark blue line will be kind of the result that you'll get from a LEAFF simulation. And so with this specific scenario of this window, it's as you can see from the title, it's a double glazed 3 millimeter with an aluminum spacer, reinforcement, insulation, no divider, no interior low E. So it's a very specific subset of a specific frame that has this particular trend line. And so the reason why we need to get so specific is because if you look at this plot, this would be all of those points would be say all of the different ratings for all of the different windows in a product line. So I see Ivan just came on. Hi, Ivan.
Yeah, it's not Ivan, it's John Layton.
Yeah, so there we
Hey,
go. So,
John.
So Jomo, thanks for figuring out what was going
Oh
on
my
there
gosh.
and getting in. So
I
welcome
had to-
aboard, and I'll pass it back to you guys.
Yeah, sorry guys, I had to jump. I can't even figure out how to turn my camera on, but I had to jump to Ivan's computer and I could not figure out why my computer kept giving me an error message that I was in this death spiral. So I'm glad to be on here. Thank you, Taylor, for taking off, and I may turn it back to you here because you're right on the money there, Taylor. This is an example of plotting essentially the same frame with different variations, and I think there's some triple glazed and double glazed in there as well. And yeah, we can plot kind of an average line, but it doesn't follow that slope. And because there's so many different variables, there's no way to use that slope calculation as the independent, the X, just the center of glass. So basically NFRC, when they first started going down this route of like, how do we just use the center of glass to determine along the trend line what you'll have if you change out your glass, I realize there's a couple categories or rather grouping that you have to do to eliminate a lot of to make them into individual trend lines. So Taylor, you can add on that or whatnot.
No, I like the way you explain that, John. So so yeah, you can see in that bottom right hand figure, it's the same frame, but there's many different iterations within that frame. There might be a different spacer, different reinforcements, different insulation. And so if you put all of that on one graph, it would look kind of like this one. And you can see there is a trend line, but it can't really be plotted. So that's why you need to separate all of those into their own trend lines, and then you can get a good definition of each trend line. Now we got Ivan and John on.
You fixed it? Oh my gosh, I don't know how he did that. Sorry. Oh, I'm not muted. Go ahead with this, Taylor, and I'll get over to my right spot there.
Okay, let me know when you're on. John can explain things a lot better than I can. So so with each different John, you're still unmuted, but with each different trend line, there's different categories that you need to go through to establish what changes would make it different enough to bump it into a different trend line category. And so these are the main differences that we need to look at as simulators to make sure that we're not lumping things into one trend line that should be separated out so that we can be the most accurate with our results. So and these are things that are good to know for manufacturers, just so that when they're establishing what their different product lines might be, that they can know, okay, if we want to have a different spacer, if we want to have 5 different spacers, that'll be 5 different trend lines. And then that stacks up because you need to have three different glass simulations for each trend line and whatnot. If they want to add in reinforcements, then that'll be another trend line. So multiply that by the number of spacers you have. Then say if you have 2 reinforcements and 3 different spacers, then you got 6 different trend lines there. So
yeah,
John,
I'll add to that. Good to finally be on. I was, when I was going to start off, I was going to say that LEAFF program is not that complicated, but hey, just getting on Zoom was complicated today. So yeah, so Taylor's exactly right. It has to separate categories. I think the important things to really understand is that as you go through the list, this tool that NFRC is set up is a multiplying list. So if you have monolithic and laminated, it essentially splits into a tree, and then it will continue to multiply all the way down to identify how many different trend lines you'll have. That things to keep in mind are, if you have a product line that's reinforced but doesn't have grids, it won't know that. That's information management that would have to come to a modeler, because it would be included in a trend line, because it's further down the list, and that's how the multipliers work. First it does the IGU characteristics and then the frame characteristics. So it's just important to recognize, are these features for all product lines, for all this product type, or are they specific to certain ones? Because even though the thermal modeling may be the same, you may end up with information or values that are just not pertinent or not real, something that you could actually deliver to a client. So I think that's probably the most important thing on the multiplier list. And so here's a really good example of the different, like I'm sure Taylor, you touched on traditional modeling. We have to model every single variable, even if it's the same frame. If they're going to use reinforced, we got to model that, and the one that's not. So here's just an example of why trend lines can be useful and helpful. So before, as we said, you have to simulate with an IGU that's like a midpoint, one of the lowest, one of the highest performing. But when we put this through that trend line calculator, essentially, we're like, do we just have one monolithic, just double glazed only? There's 2 different spacer widths, cavity widths. There's no interior facing, low E, no grid. So it's kind of multiplying down, no dynamic glazing. And it tells us we need 8 trend lines. So we model those 3, and it's only a total of 24 total product simulations that are required, which sounds like a lot, but when you compare it to the traditional method, we would have had to do 72. So it can cut down on the thermal time and the time for you to get your products certified substantially, a lot quicker, because just eliminating essentially the copying of information when everything else, when the center of glass U value is the only variable. And so here's just like an example of that, and furthering the point of that endpoint, midpoint, the 2 endpoints and the midpoint. So these are determined based on the glass options that the manufacturer wants to supply. And you can have as many as you possibly want. Keep in mind, because of the categorization, if you have a double glazed to a triple glazed, those are obviously going to be separate. If your cavity width is different, then those are going to be separate trend lines, but we can still put those into different groupings. But when it's broken down to, if it's the same cavity width and there's no interior low E coating, all glazing will, double glaze will all be in the same. So if you have 100 different types of glass you want to offer, that's fine. We only have to model the 3 that are applicable to that specific category. One thing that we sometimes see is people have laminates, but they only have like 1 or 2, or maybe they don't have 3. There's only 2 options they want to look at, which means it doesn't, although we're still following the LEAFF protocol, but we can't do this. So it's more of a traditional method, because we have to model them each independently. But when we get all three, it allows us to essentially make that straight slope in which we can extrapolate, or rather put in the next solar heat or the solar heat, I don't know, I'm stuck on that center of glass value. Taylor, if you go to the next slide. So we essentially, we're establishing our, regression line equation. And so we have y equals mx plus b. We know the m and the b. So the x is that center of glass u value. So you can just multiply that in. As long as you have those three plotted, any IGU that you come up with after, you can put that in. So if you have to turn on the fly, for instance, on a project, we had a few where people had to change glass quite a few times because just of glass ordering. This is a really quick way to find out what your overall U factor is going to be. So it's really just a line graph equation. And then Taylor, you have the next secret sauce of the LEAFF program, the thing I think they're sending out with it because they want to have people adopt over to that. So go ahead.
Yeah, I think LEAFF is, it's a positive change in and of itself. But a lot of the changes really fall on the simulator side for us to figure out, all the different categories and whatnot. You won't see a large difference on the labels, for instance, or how things are done from your side. But this condensation index is a new thing that I think is a little more exciting, and I think will be more applicable in the future going forward. So condensation, it relates to those other lines on the graph, the yellow, the red, and the greenish line there. And what we're doing with the condensation index is picking up on the glass, the edge of the glass, and on the frame what the lowest temperatures are within a certain distance away from gaskets and whatnot. So what we can do with that lowest temperature is we can calculate the CI using the CI, which is the condensation index. Using those variables, we can calculate that to know whether or not condensation will develop on the frame or the glass, which in Canada is often an important factor. So NFRC did have a condensation value, the CR value, which is I think some of you probably have on a rating for that on your systems. It was good for comparing, apples to apples between products, but there was lots of downsides to that value, which the CI corrects, I feel like. So the condensation resistance, the CR value, it was calculated using a whole bunch of finite element analysis and calculations in the computer, and a whole bunch of voodoo type stuff that nobody really understood. And it makes it hard to really error check that type of value, where the CI rating, it was actually developed in Canada and using physical testing methods where they're actually putting thermocouples on the frame in a specific spot, on the edge of the glass in a specific spot, and then using that simple formula to give you your CI value. And the added benefit with that, aside from it being simpler to understand, it also can be applied to all different site conditions. So once you have your CI value, you can pull up this table, and you can use your site specific conditions. So say, for instance, your relative humidity, in your interior relative humidity, you might want to have 35% relative humidity. and then your exterior design condition might be -25. And so with those, then you can calculate, okay, I need a CI value of 65 to know for sure that it won't get any condensation with those conditions. So it just makes it a lot more applicable for site-specific conditions. If you have a pool that you're designing for, say for instance, then you're going to need a lot. You're going to have a lot higher relative humidity. You'll need a lot higher CI value to be able to handle that. And different conditions might not need a high CI value. So so I think this will be an exciting metric to have going forward. And as John mentioned, it goes hand in hand with the LEAFF. They've kind of tied these together, I think, as an added selling feature with LEAFF, so that if you want to have a CI rating done, you actually need to go through the LEAFF process to have that done with it, in the States at least.
Yeah,
John?
yeah. Well, I was just gonna say, we were already doing temperature index, like you said. We were kind of forcing therm. You could check temperature values, but I mean, we had seen, there was a local architect who contacted us about a pool project we hadn't worked on, where he's like, my wake up in the morning and the windows are all got condensation all over them, and then by midday the south side's all clear, but the north side's still just got a coating of water on it. How do we get rid of that? And it was kind of, to go down the experiment. I said, well, the option you have is replace all the glazing, or we're going to change your you got to talk to somebody with HVAC, because you're kind of stuck where you're at. And I think what the intent of this was to essentially make a more automated and precise calculation, which is really nice, because I don't think anyone in the past has been like, well, condensation, whatever, does what it does, and you'll just deal with it on site. And especially on something of that scale, like a university pool, it's just that this is just a precision tool that I think really helps to that you can check with your system right off the bat at the estimating stage, so confidently that you're not going to have that issue. And then I know most of the time you want to start off with the advantages and build it up, but there are some disadvantages of LEAFF, and in our opinion, I'll put it that way. One is heavy on information management. I mean, you could imagine when you have 24, 35 trend lines, the naming of trend lines is something that like we can create, but we prefer to have the client tell us how they want it, because it can get really complicated really quick, and you miss. I think Taylor showed the one shot that said like 3 mil glass, low E coating on surface 2, like it's on and on reinforcing, no grid. Like you miss one of those indicators and you'll have a different value than what you should be reporting. So there's a lot of information management on our side, making sure that we create the trend lines correctly and then name them correctly to pass on to the client to give them a proper matrix. But in all reality, the most likely option is like kind of a dynamic spreadsheet that is not provided by NFRC. That'd be something that we could either put together as someone's pursuing certification, or that the client decides to put together, because hiring new employees or whatever, not understanding exactly what they're looking for. Like that is, in my mind, one of the most difficult hurdles that everyone's going to have to adopting. I know it's new and it's kind of weird, but we can get our minds around what LEAFF is trying to do. The problem is, how do we practically use it? And information is where I think the biggest challenge is going to be. It also, if you say you have hired a certified simulator, or a guy who does it, in order for the LEAFF certification to be recognized at a simulation stage, they have to be a certified simulator first, and then they also have to receive the LEAFF certification. So Taylor's done that. I just did a training right now. I'll be shortly, but we have 4 of our staff who are, and it's an additional thing. I mean, that's hard. And if you're not working on it every day, you can miss some of the some of the rules. So it's a challenge that is not solved yet for certification on a wide scale. Also, it doesn't help. One of the things that we know we're talking about in BC and across Canada for site specific or custom sizing, it's still based, and NFRC is focused primarily on giving certification to a standard size. That's one of the variables they're just not focused on providing information for. Now, when we build systems, we record what the edge U factor is, the IGU U factor, and the frame U values to get a total U factor, which then we can use the variable for size change. But that's something, if you just get this information, you get it certified, you're still stuck at that standard size. And it doesn't currently report solar heat gain or VT values, which are traditional to a label. Now, for the 3 that are done, that are fully modeled, you can have those. But this is something that we're still trying to learn. Is this still follow a linear pattern? And if it does, what does it jump by? And I think there's just more playing around that needs to go with that. Doesn't mean you can't get labels for your stuff because it's based on those values they have. But if you needed to know specific, say an engineering modeler wants to know specific sizing, and according to what you're professing the values you get, it's more information that you need to dig into. And this is, in my mind, it's an advantage and a disadvantage. What we stuck it on here is it disproportionately benefits those large manufacturers. I think NFRC really was had the guys knocking on their door saying, hey, like every 5 years we have hundreds of or thousands or hundreds of thousands of products that have to be recertified, individually modeled. We want to, why can't we kind of group things together? So they did that, and it helps those with large SKUs, but those who may have limited options, and which is fine, and it could be a very high-end product, you may still fall more under the more traditional method, or only see minor benefit for what now becomes kind of an information management headache, whereas before you could just pull up your list and be done with it. So in my mind, that's a little bit of a disadvantage if you're not a large manufacturer.
Okay. We have a call after this call, so I have to stop before the top of the hour. So I'm gonna actually stop you guys there if I can. I do want to get to some questions from people attending, and also I have a few questions as well. So I'm going to start with mine first because I'm running the show, so I get to do that. So I'm just a manufacturer, I don't understand all this stuff. I don't understand trend lines, et cetera, et cetera. So, what I need to know, will my reports be the same?
Your reports will be different in the sense that they're going to be based on this trend line value. And so your group, whatever that grouping is in, it will all follow under that one single report based on that trend line. And so like your product that's reinforced will not be included necessarily in your product, or won't be included in the product that is. Did I say that right? The one that's reinforced won't be included in the one that is, the other way around.
Okay.
So because they're categorized separately, but it's based on the center of glass, right?
Okay. So I could potentially have more reports.
Yes.
But within those reports, I would still have the same level of accuracy for all of my different options within that one report, right?
Yeah.
Right.
Okay, fair enough.
Then instead of maybe a long table of all the different glass options, you would have less lines on the table and a formula to calculate whatever glass option you would be using.
Okay, so I wouldn't have every glazing design within that category listed in my report.
No.
Right.
Oh, that's interesting. Okay, good to
know.
know.
Now you can, because it tells you what essentially what your X, here's X. It as long as you have your center of glass value, plug it in here, and that'll give you your total product value based on the end points and the midpoint of the center of glass that you select.
Okay, so it sounds like there might be a little bit of work for a manufacturer to do if he needs additional detail. Okay. Is there a sweet spot for the number of options where LEAFF makes more or less sense to use? Like you mentioned, it sort of lends itself to larger manufacturers. Is a smaller manufacturer do they just keep doing what they're doing today, or, you know?
As long as they want to use more than 3 glass options, it is an advantage to them, because it's less modeling time, less cost for modeling. Like I know that like we can model per system per job, and the price isn't very expensive. It can range on your product, whether it's fixed window or sliding glass door, but overall that's like a quick way to get it done what you need to for that project. But if you want to keep selling and advertising and getting architects to buy into kind of, hey, here's all the glass options you can choose from, you only need to know those 3, and then you can use that multiplier and you're fine. So as long as you have more than 3, there's no reason not to adopt to it. Glass options, I would just say the sweet spot really is how much time and energy of adopting to the program manufacturers are willing to put in, because it's not like you can just identify it as a single number. What I mean is I can't say like, okay, my one frame is this SKU number and that's it, because that one frame could have 4 or 5 different trend lines that they're all involved in because of different options that each of those frames have, or the cavity width or whatever, if it's part of the IGU. So that's where that challenge comes. And yeah, that for me, I know I'm a pragmatic person. I'm like, okay, I get what NFRC is doing here, but I also understand that there's some amount of information that's putting on you to manage, which can be a challenge.
Yeah. Okay. What about grouping of products? Like currently my understanding is you can group an awning window and a casement window using the same frame system into one report. Is that still possible within a LEAFF setup?
Yeah,
Go ahead, Taylor.
they would each have their own trend lines, but they would because it's a different size.
Okay.
But it could be in the same report. Yeah.
Gotcha. Okay. Do you think that CSA is going to adopt LEAFF down the road?
I think they've acknowledged that it's that they'll accept those values, but they so I think they sort of have already accepted it, but they're not like pushing it as a requirement at the moment.
Okay.
So,
I kind of think, well, Taylor, did you already tell them that no, as far as we know, no one has gone for LEAFF certification yet?
Yeah, we should probably point out. So we're in kind of the trial phase of LEAFF. So it was started in just this year. And as far as we know, no one's actually gone through the certification with LEAFF. Okay. But starting the beginning of next year is their plan to enforce this. And
they gave a 12-month like window to do it. And so if anybody's product certification was ending this year, to be totally honest with you, if I'm used to the old way, probably going to do it the old way until they actually tell me I have to.
Yeah, for sure.
So I actually believe CSA is essentially saying, like this is just our opinion. Yeah, we know that the NFRC doesn't. Yes, we know that we kind of joined the NFRC bandwagon, but we'd like to see some real world application before we say give the thumbs up on it.
Yeah. Okay. I do have a few more, but I'm actually going to open it up if there's anybody online that has a question. There was one question that came, it was from an anonymous actually. CSA certification, does it expire like NFRC? I don't know if you guys are involved with CSA thermals, or if I don't recall. It's been so long since I was involved in the CSA program, so I actually don't recall.
Yeah, CSA is a little looser on that than NFRC. So with NFRC, it's every 5 years you need to have recertification done. CSA is a little more subjective. They basically say if the products have changed enough to change the results, then you need to have it recertified, which could be more or less than 5 years.
Right. Okay. Yeah, fair enough.
More of a gray line.
Okay, nothing online yet. Taylor, you mentioned something about labeling potentially being not the same as what we do today. Can you elaborate on that?
Maybe that came out wrong. I don't think you'll see a big difference on the label, because when you're putting a label on a product, it has a specific glass type in a specific frame. So you would actually print the label out for that. So I think that the label will stay the same, but on the back end to put the numbers on that label, you'll need to plug in the glass type that you're using for that frame into the formula to get those numbers.
Okay, gotcha. Okay, a couple questions here from Jag. So how do you determine the coldest part of the product?
So that's the nicest part of the new CI tool, is that we're not determining it at all. The actual tool is running the therm model, and it's pinpointing where that is. Now, it is generally in the same location. It's going to be essentially there's a part of the frame. Taylor,
So it has to be half an inch away from the gaskets, the glazing gaskets, and on the edge of the window, it needs to be an inch away from the gaskets. So that's typically the coldest part, but it can be anywhere on the frame. And so the CI tool pulls those numbers a little more quickly. We used to have to go into each therm model and pull those out manually using a temperature tool.
And we were like searching for it. So you'd be like, like going all over the place to try and find it.
Oh man. Okay. So Jack's got another question here. Glazing varies based on surface 2 or 3 low E's, I'm assuming. It's really common to have that variability. Do they need different trend lines? So if you're putting your coating on surface 2 or surface 3, does that generate a different trend line?
Nope. No, they're totally fine, and they're the same trend line.
Okay.
Another question. Same with gas fill too. Like as long as the cavity width is the same, then the gas fill that we can, you could put an air as your highest boundary and then down to Krypton or whatever.
Okay.
Yeah.
Question from Sudhir. So are the LEAFF thermals accepted by NRCan, and how are these simulations are different than conventional modeling? And actually, I just want to add a little bit to that, because you mentioned that solar heat gain numbers are not being generated. I think that's what I heard. So will that not impact getting into Energy Star NRCan programs?
Yeah. So Taylor, I'll jump on here first. What I mean by that is, so when we do the three actual generated models, which are based on the center of glass. I mean, to try and replace solar heat gain and center of glass every time I mind. When you generate those 3, you get all the information that you need. When you're plotting that thing, however, it'll only on the trend line, it's only using the variable of the center of glass. Now, I haven't played around with this enough, partially because no one's actually pursued this, to know what is the linearness of the solar heat gain. There's going to be some adjustment. I just don't know. Is it just as easy a calculation? And when I just completed the LEAFF training seminar, and I know when Taylor did it before, there was no explanation of how solar heat gain coefficient comes into play with here. So it's honestly I don't know. That said, all the simulating, all that remains the same. None of that changes. If anything, it's just trying to minimize the amount of simulations that done, but like it's still the same type of simulation. You're just trying to group things together. Taylor, you had some other.
Yeah, so they're not getting rid of the solar heat gain in VT. It's just not part of the whole LEAFF method. And I feel like there was another part of that question.
Sorry, guys, a second call going there. Question from Kyle. So with the trend line using 3 IGU options, base, mid, and high performance, what value would come out for an IGU option that's mid-high? Is that an input into a spreadsheet that the manufacturer would plug in? That's what I think I heard too. So can you answer that one?
What do you mean by mid-high? Like in
between
there?
I think what he's saying is if you have 3 glazing options, a base, like a low, mid, high glazing option, and you have something in between and you need the values for that, the manufacturer needs to do some work to get that number. Is that correct?
Yes, it's actually just plugging the center of glass U factor into the equation, the linear equation. So you take that center of glass U factor, plug that into the equation, and that will give you your total product rating.
It's your X value and the Y equals MX plus B. So your trend line determines your M, your slope, and B. So then you just have the X to solve, and that is where you would plug in any of the other IGU values that aren't the mid point, the high point, and the low point.
Okay. Maybe we have another session just talking about that, because that sounds like it's going to be something that manufacturers might be a bit challenged with. Couple of quick questions here, because like I said, we need to get off earlier today. So from Jag again, during the NFRC annual testing, we found that there was variability between simulators. Well, yeah, okay.
Yeah.
I don't think, nobody's surprised by that. Does this make the industry more open to result variance between simulators, and can people misuse that? Interesting question.
That is a good question. I think that challenge has always been there. There is a bit of an extra check with the LEAFF method, because with each trend line, you do need to have your error within certain bounds. So if you have one model that is way off the chart, it does kind of flag that for you. But yeah, that differences between simulators will always be a challenge.
Okay.
I know that NFRC in their last, whatever, like each year we have to do a recertification test. They, it was not a round robin this year. It was like pass fail. And so there were a significant number. I wouldn't say it was a lot, but a significant number that were told you gotta go back to the drawing board because they had not passed. So.
Well, okay. I'm really sorry to cut this off, because it's a great conversation, and I think maybe we need to do a follow-up to it, digging more into what it means for a manufacturer. So I want to thank you guys today, Jomo and Taylor. Great FenCan supporting member. We love working with you guys, and it's always really interesting stuff that you bring to us. So appreciate your joining us today. And I just want to plug the next Tech Talk session, April 27th. Can you hear me now? Talking about fenestration acoustics and acoustic testing with QAI Laboratories. So thanks very much, everybody, and we will talk to you soon. Thank you very much.
Thanks, Gary.
See you guys.
Take care.
Bye.